matrices. Any question?
No, no question, sir.
No question. No question, then we look at the next page. Oh, so many questions here. Oh, this one, this one is about net force. If there is net force, then the object is no longer in equilibrium, right?
Okay.
Forces, they don't balance one another. If the forces, they don't balance one another, you have to look for the net force, the F net. Okay, you have to look for the net forces, the net force, only one. Okay,
Okay.
so the first case, whether got net force or not, you read and see the first example, 4.8.
Suppose a child of weight climbs into the slit. If the tension force is measured to be 60 Newton, find the weight of the child and the magnitude of the normal force acting on the slit.
This is related to this question here. It is tied to a rope. So if it's tied to a rope, it's still not moving yet. So there is no net force. The four forces, they balance one another, right? Normal reaction and the component of the weight, tension and the component of the weight. So they balance one another. Now, when a child climb into this ledge, the total weight is no longer 77. It is 77 plus W. You see, it's a diagram given here. Okay. Okay. So this diagram here, we transfer over here. So when the child climbed into this sled, the weight, the combined weight of the child and the sledge is not 77, but is W plus 77. So all this mg thing, all the mg is actually the weight of the child plus the 77, the weight of
Okay.
the carriage. Okay, plus. Okay, so this is what I'm trying to tell you. The total, the combined weight is no longer 77. It is W plus 77. Okay, right. We want to know what is the weight of the child if the tension is 60. The tension is 60 newtons. So we look at this for this equation here. Now this equation tells us that the tension which is pulling them upwards is equal to the component of the weight mg sine theta. So these two, they balance one another. So I say tension equals mg sine theta. But it is given that the tension in the rope is 60. The tension in the rope is 60 degrees. So I replace the tension here with 60 degrees. Mg sine theta is the combined weight of the object and the child. So I replace this mg with 77 plus W. I also know the angle is 30 degrees. So I put down 30 degrees here. So what I'm doing is that I substitute everything that I know into the equation T equals to mg sine theta. Everything I know, substitute inside. What is my aim? My aim is to find out what is W, the weight of the child. Okay, so W plus 77 is 60. You bring the sine theta over, 60 divided by sine 30. 60 divided by sine 30 is 120. It means that the weight of the child plus the weight of the sled is 120. So the weight of the child is 43 newtons. Okay, 43 newtons.
Mhm.
Now they ask us to find what is the normal force acting on the sledge. So what is the normal reaction? Now from the diagram we know that the normal reaction is mg cos theta. The normal reaction is balanced by the time mg cos theta, right? So I copy down the equation here. Normal reaction is mg cos theta. Mg is the combined weight of the two, the child and the sledge. 43 plus 77. This is the child, this is the sled. And cos, the angle is 30 degrees. So if you use your calculator, you multiply out this, you know that the normal reaction is 103.9. In the book, they round off to 3 significant figure. They give 104 newtons. Okay. So what they are doing here is they just balance the normal reaction with the component of the weight, the tension with the component of it. It is at equilibrium. It's still not moving because it is hang on by the rope, so it's not moving. So I can say that all the components, they are equal, right? The net force is 0. So by substituting numbers into this balanced equation, I can find out all the unknowns that they want. I think we stop here.